Look at the cases here. The well-known Deepwater Horizon blowout, and in 2009, Mumbai High wellhead platform, and in 2005, Mumbai High, and the world-famous Piper Alpha. Again, without profit, every company will not survive. We are talking about safety as well as an equally important subject, profitability. Your business depends on productivity, and thing is that the cost of safety is always indirectly or directly tied to the profit of a company. An unsafe company will certainly pay out more in terms of fines, in lawsuit, as well as the lawyer fees. And if you are deemed unsafe, normally you will have increased premium on your insurance. All these payments directly affect the bottom line and the cost. So we are talking about operators constantly balancing between increased profitability and driving up plant productivity. And they don't like to compromise what is very important, is safety. Today, every safety case must drive profitability. What drives plant productivity? Look at here. Initial process design is important, and not to say selection of a reliable equipment and implementation of the most efficient maintenance routine as well. Today, we are here because of the market demands and the price. The oil price is quite good. This morning somebody told us that once you shift from $60 per barrel to $75, you are there for business. So constant plant uptime and controlling operating costs is another factor to drive plant productivity as well as profitability. So how can a safety system improve your plant productivity? In today's ideal situation is that you would like to have a safety system that must never be a cause of a failure for any reason. FPSO owners and operators are becoming accustomed to unnecessary shutdown. We are talking about unplanned shutdown as a result of spurious trip, periodic close testing, hardware, software upgrade, which is sometimes mandatory, and it causes problem because it just shut the system down. The safety system, invariably, if it's shut down, the plant will be shut down. And also common cost failure. Already, we are hearing a lot of messages this morning about operators and owners expecting suppliers to consider the CapEx as well as the OpEx. And why? Because they want to save money. Saving money is what they are looking for, and these are the three key elements that we can see. They want to buy only what is needed. What we're trying to say is that they want to reduce the capital expenses. The system must be scalable, and they want to save money by reducing life cycle costs. How to reduce life cycle costs? Simply by operating non-stop. That means you are not dictated by a safety vendor who shut your plant down because of unmanned shutdown and routine upgrades. Saving engineering money using a flexible, intuitive, easily adaptable platform. So this is what they are asking for. And what is needed now and in the future is a safety system that will deliver 100% availability and never affect the plant uptime. And a safety system that will help you generate more revenue, and the safety system Most importantly, to support the business case here, to reduce the capex, which is the purchase cost, as well as the OPEX. HEMA understood this because of a survey done a few years ago. What is needed in the future? We introduced the HIMAX, which is the first safety system that improves productivity and profit. Why HIMAX? Because it saves you a lot of money. There are 3 reasons why HIMAX released here. Availability is 100% system availability for the life cycle of your entire project. At the same time, 100% flexibility is a 100% unlimited online changes on hardware, software, even operating system changes non-stop while the plant is still running. You no need to shut the plant down anymore. What's more, it offers unrivaled performance with the latest state-of-the-art technology. HEMA, HIMAX stay on non-stop. Never have to turn off your system anymore. It's 100% system and plant availability through no single point of failure architecture design, and it allows users and operators to carry out any modification online while your plant is in operation. At the same time, any operating system upgrades, you can add, delete any user program, add, delete any communication protocols, CPUs, I/O, and even the entire new system and entire hardware and I/O and racks and cabinets. In addition, it can perform mandatory proof testing online without even have to shut your current system down. We are talking about XMR, is moving beyond TMR fault tolerant functionality. The XMR advantage is it always gives you SIL3 with no restriction even in a simplex configuration, or the European call it mono configuration. Scalable availability with more level of fault tolerance, spurious trip totally eliminated, highest availability. Let's look at the XMR technology. When X is equals to 1, you already have SIL3, highest integrity in a safe integrity level for a PES system. The architecture is single input, single output, and single CPU. The benefit for this kind of architecture is a safe architecture for process facility which do not require redundancy. When X equals to 2, you already have SIL3 as well. But here is a little bit different. The architecture is a dual input, dual output, dual CPU, most widely used system for particularly on safety, where you need absolute safety as well as availability. When X equals to 3, it refers to an architecture where you have 3 input, 3 output, and the 3 CPU. Here, this is where the availability is more than enough. This is to answer for traditional hardcore people who want TMR architecture. And X equals to 4 is unique in the market. This is the only system in the market that have X equals to 4. Is quadruple input, quadruple output, quadruple CPU. This is an application where we foresee is for nuclear plant application where you can really eliminate common cause failure. Look at TEPCO in Japan. There is a tsunami, it wiped out the whole case. That's it. If you have an XMR technology, it solves that problem. Let's look at the non-stop advantage. Say for example, you have a mainstream boiler running. Then you have a plant expansion and upgrade, you need an auxiliary boiler. Hook it up, do all your testings and everything, the hardware and the software, do FAT prior to installation, download the changes while the plant is still running. We are saying the plant is running while you are doing that, and hook it up, you have an entire new boiler without shutting the current mainstream boiler. That is really amazing. The next thing we are talking about, say for example you have a SIS upgrade online. The original version of the emergency shutdown is version 3.3. Then you have a plant expansion with new functionality in version 4.5. What they do is they do the same. You do FAT prior to install, upgrade the OS to the latest version 4.5, you get the new functionality and you get a plant expansion while the plant is running. So we are saying there is a lot of advantage when you are operating non-stop. Typical plant experiences several days of lost production over the lifetime due to unplanned, I'm referring to the unplanned shutdown to maintain an SIS. No more, you don't have to do this and face this problem anymore because IMAX gives you back all that production loss, the revenue and profit back. One day of shutdown may cost a few $1 million. Flexibility, unrestricted online changes. This system, let me emphasize, is fully online expandable. The good thing about this is that you can buy only what is required at the start of the project, which is you can reduce your capital expenses. You don't have to buy up front, you buy what is needed. When you need to expand, you buy extra. So you expand your system as the plant or the project grows. Unrivaled system performance. If you are familiar with a safety system, look at this chart here. For a typical 2000 I/O point with a split of 50% analog and 50% discrete point, the scan time is incredibly fast. This is less than 100 milliseconds. What's more, it allows parallel processing and multitasking in a single controller. IMAX is used in process safety, critical control applications such as ESD, burner management system, fire and gas system, and TMC and the HIPS. We have launched this product in year 2008 and we have a lot of very satisfied customers. Some of the references here, Ebonic, Miro, Shell in Hamburg, as well as the latest one is Shell in Canada, ExxonMobil, Angola, and some work in progress, which is the project is still running. This is the biggest installation greenfield project in Australia by impact. It's a 20,000 I/O point, roughly there. So we have lots of references within a short period of time. Let me conclude. Choosing the right SIS. The key factor to consider is that you have to consider an SIS that drives plant profitability, have maximum availability, improve life cycle costs, and offer you the maximum safety, which is SIL3. And let me emphasize, if an SIS can keep the OPEX cost to a minimum yet only shut down on real process demand, this is a criteria that you should choose. Think long term. Do not be short-sighted. What I'm trying to say is that sometimes we cut costs try to implement the minimum requirement to satisfy regulatory requirement. That may not be the ideal case. In the morning, somebody told us that if you want to manage your plant operation, the OPEX point of view, you should consider a well-designed system. So this is vital. The SIS has final control over the plant, how it runs and how it shuts down. So it has an overriding safety function. So be in control and specify the right SIS. I'm running